be using a software called EasyEDA, and there's actually like a whole bunch of things you can design PCBs in. I know like KiCad is popular since it's open source. There's also like Eagle, but EasyEDA is nice since it's completely online, so you don't have to download anything. And it also is like made by the same company. I'm not sure, but they have like some sort of relationship with JLC PCB, which is where I get my PCBs manufactured. So like the process of like taking your design and getting it manufactured is really easy with EasyEDA. So it's on the doc and it's just at easyeda.com. So if you go there, you might have to like make an account and log in, but just open the like editor. So once you get here, file, new project, I don't know, NFC business card. And then just click save and it will like open it up here and then open up this interface. This is the schematic editor. So when you're making a PCB, first you make a schematic, which sort of shows all the different components you're going to use and how they're like electrically connected to each other. And then you can convert this schematic into like a PCB diagram, which shows how everything's going to be printed on the board. So once you have the schematic, it makes it easier to like route the traces on your PCB. So we will be starting with the schematic. Is everyone good at this step? Okay. So the parts that we will have on our board, they're listed on the Google Doc. But here's like the data sheet thing. Basically what it's going to do is we have this chip, that's the NFC chip, and it also can like harvest energy. So that's how it's going to power the LED. And this sort of explains how we need to like wire up the chip to different components. So there needs to be an antenna, which is made just by using like metal in a loop, and then it's connected to this chip. There also needs to be a capacitor, and we also have a resistor and the LED for like lighting up the LED. So those are the main components that we need, and then we can sort of look at these to see how like we need to connect them. Okay. So on the sidebar here, there's the library button. So if you click that, and then we'll just add in the NFC chip first. If you copy, I think it's like the part number, and then either LCSC or JLC PCB assembled, but you should just be able to find it. If you click on it, click place, just drop it in the middle there. Okay, and then you can see that it has like a bunch of pins that are labeled. And if you go to the data sheet, you can sort of see that it's the same pins. So on page 9, you see that LA and LB are where the antenna connects. The antenna is just like the loop of metal that harvests the power. So we will also need the antenna. And since the antenna is literally just a loop of metal, it's not really a part that JLC PCB can assemble because there's nothing really to assemble. But there are like user contributed footprints for this. So if you go there, I think this is the one I'm using. It sort of looks like this. It's like 25 by 48 millimeters. If you search NFC antenna, you should see it. And then you can just place this here, I guess. And from the data sheet, we needed to connect it to LA and LB. And the way you do that is there should be like a wiring tools panel floating around somewhere. And then you click just this first one. Then you can use like the green thing to draw a line. Does that make sense? And then if we look at the data sheet again, so it says you need a capacitor between 150 nanofarads to 220 nanofarads between V out and ground. And ground is actually VSS. If you go to page 9, you'll see that it says that there. So we will add that capacitor. Yeah. Okay, and to find capacitors, so JLC PCB has a like super large parts library, and some of them are basic parts, which are like more commonly used ones, and they assemble those for cheaper than like other parts, which are extended parts. So I basically just went to the parts library and then searched for capacitors with the parameters that we want to have, which is 220 nanofarads. And then just like, you can select search for basic parts only. And then it just found one. I don't think it matters too much exactly which one you use. So the part number of the one I used is this. And then if you go to library, plug it in, and then switch it to JLC PCB assembled, you can see it and then place. And as the data sheet said, we wanted to connect it between V out and ground. Ground is VSS. So we will do that. So after we have the capacitor, then we can add like the LED that we actually want it to power. And oh, one more thing. Okay. So we don't have like external power to actually power this chip. So we're just going to use like the harvested energy to power it. So that means we just connect VCC to V out. And we can do that just by connecting pins 6 and 7 here. And then we have the LED and resistor. So let's see. Same deal, just go to the library and plug in this. This is a 47 ohm resistor, which can be sort of calculated from the output of the like NFC chip. It's supposedly 3V according to the instructable, but I'm not exactly sure where they got that number from, but it seems to work, so. And then the LED, I think, is around 2 volts. Okay, so we have these two, and it needs to be connected between like V out and ground. Basically like a circuit. So this is the schematic, and then next we'll turn this into the actual PCB design. So to do that, you hover on design here, and then you convert schematic to PCB. Just keep going, it's fine. Okay. This is asking you for the board outline, which is how big the actual like board is going to be. And we can use round rectangular just so it's like rectangular, but we can round the corners. And according to Google, business cards are 3.5 inches by 2 inches. So we'll do that. So fill those in, but it doesn't matter if you filled it in wrong because you can always change it later. And then once you click apply, wait, did I calculate that right? Okay, I think I typed wrong. Whoops. But if you want to change it later, you go to tools, set board outline. And it's apparently 88.9 and not like 76. I think I typed wrong earlier. And this pink thing is basically the board outline. It just shows you how they'll cut it. So like how the final PCB will look. And might as well save it while we're at it. Always good to save your work. Okay, and so this is actually how the PCB will look. So where you place like all the components does matter. You'll see that since we converted the schematic to the PCB, they dropped all like the footprints of the parts we use. So this is the antenna. This is the NFC chip, resistor, capacitor, LED. And there's these like blue lines that are going between different pads. That just shows you where you have to like actually draw the electrical connections, which are the traces on the PCB. And it's pretty helpful because then you can see like which pads you have to connect. We'll use the auto router to do that. So okay. So to rotate things, you can select it, hit the space bar, and we'll just rotate this so that it like fits on the bottom here nicely. You can put it somewhere else if you want. One thing to note is that this is the antenna, so it shouldn't have like copper stuff inside of it. So it disrupts the signal, I guess. Then you can rotate it so that the lines aren't like crossing as much, which will make routing it easier. I think I put like and you'll also notice that there's different colors. If you look on like the layers thing here, see that red is the top layer. That's basically where they are putting like the copper on the top. There's two layers to this PCB, the top and the bottom. So you can have like different like 2 layers to do the electrical connection so that if you want to cross things, you can do something on the top and then do a hole to the bottom and then cross on the bottom. Also see like the yellow stuff, it's top silk layer. Silk screen is usually used for putting like indicators like this, but we can also use it for art as we will see later. And since it's just silk screen, it's not like electrical anything, so it's fine if it overlaps. Okay, and then the LED. You can try to line them up, or you can just like leave them. Does not matter too much, I suppose. So this is a business card, right? So I'm going to add my name to it. And there should be a floating panel like this that says PCB tools. There's a text tool, and then you click on it, click on the screen, and then it drops it there. Then if you double click on the text, you can change it. So I'll just change it to my name. And also if you select the text, you'll see that there's like text properties on the right here. And then you can change like the size of it or the line width. So that'll just make it thicker. And this, it placed it on the top layer right now, but we can put it on like top silk layer. So it's just the silk screen.
Top silk layer.
You just drag it around to place it wherever. And remove this. Okay. Since I have an I in my name, well, too, I'll put the light on the I. So lights up. So if you guys have all your components like placed where you want them to be, we can do the routing and we can use the auto router for that. Or you can route it by hand. So routing is just like this thing here. And then here, I guess if we route these two, you just click, and then it just routes a trace. And what this does is it puts like a copper connection between two pads, so they become electrically connected. And that's where the like thin blue lines come in handy because it shows you which ones you need to connect. But we can use the auto router just to make it a bit faster. So if you go to route on the top bar and then auto route, just click run. It takes a bit. So I would assume the one that's failing is this one here, because like whoever made this footprint, this is a pad and this is a trace, and like this trace is going to be too close to the trace that the auto router wants to put. So we can just add it in manually, but like the DRC checker doesn't like it when you place the thing like right on top of the trace. So you have to place it somewhere else and move it. But yeah.
Okay.
Let's see. If we wait for mine to finish, or maybe I could just stop it. That's probably good enough. Okay. So it was like unable to route this one, I would assume. We can route it manually, but like if you see if I try to click there, it doesn't let you because it has like a design rule checker, which generally makes sure that you're not doing anything illegal. And right now what it thinks is illegal is us putting a trace right next to this other trace that makes up the antenna. But like we actually want to do that. So, I mean, I'm sure there's better ways around it. I just like drop it somewhere else and then drag it on and then ignore it. Okay. Okay. Let's just do this. And it also doesn't want to connect to that one. So just like drop it and then drag it. And it like lets you, I guess. Huh. Why is the line still there? And like, if you go to design manager and then like refresh the DRC errors, there's like some errors. It says the drill diameter is too small. I think it's just a footprint thing, but we can make it a bit bigger. I think it wants 305. Yeah, this says the two tracks are too close together, but we do want them to be, so it's okay. Same things like here.
Is there
Option to when you're drawing the trace in the first place, ignore conflicts, and then it'll connect the two traces into like one big trace. I don't have my computer right now, but like when you're on the wire tool, it's an option in the right toolbar.
Oh, right. Yes. That is probably what you should do. Yeah, let me see. So like, nice. Thank you. So yeah, if you change routing conflict to ignore, it will let you drop it, even though it's like, doesn't want you to. Here was the like blue thing I was talking about. Red is top layer, blue is the bottom layer. So the blue is basically the same thing, just on the other side of the board, since we're doing like two copper layers. And since this, like, it's hard to make this connection just on one layer, it uses the blue, which is the bottom layer, and then there's like a hole that brings it onto the top layer. If everything's routed, the thin blue lines should have disappeared, which tells you that like everything that's electrically connected is electrically connected. Okay, so with this, you would basically have a working board. Oh, wait. So I have my name on it, and then I'm going to add a QR code to my website and then also like a link to my website and GitHub. You can add like whatever else you want. So for the QR code, we are going to use an SVG. So if you just like search for QR code SVG generator, and you can generate one. And then we can import that SVG into EasyEDA. And to do that, I don't use their like built-in importing thing because it doesn't really work that well. I use this import extension. It should be linked. Actually, is it linked? Okay, yeah, it is linked. So how for downloading? Let's just remove those. I don't have like a million. Click this thing to download the zip and then like unzip it. And then in EasyEDA, you go to advanced up here, extensions, and then extension setting, load extension, and then select files. You open the folder that was unzipped and then just select all of them and then just load extension. And then it should appear in this top bar here all the way to the right. And with that, you can import file. Let me see if I can find the QR code generator. Okay, I think it was this one. No idea. You can try entering your URL and then generating the SVG.
So
But then one note for the QR code generator, if you get an SVG from that, the importer actually can't import it because it can only import path elements, and that thing generates the SVGs with rectangle elements. So what I did was I just put it in Figma and then exported it from Figma, and then it worked. Let me see if I can demonstrate. Okay. Cool. Okay, so just downloading that.
screwed it up. Extension steady. Yes.
And then it, that's not, just delete that thing.
Yeah.
And then in Figma, you can like export it as an SVG. And then this one should be okay to import with the extension. Okay, so if you've generated a QR code and then got the SVG, or I think there is a way to import PNGs and other stuff just in EasyEDA natively, like import image here. It might work for the QR code. Not sure about more complicated stuff, how well that handles it. We'll put this on the silk layer for now, so just SVG node should work. Import scale. So I don't really know how it scales stuff. So usually I need to use a pretty small one, but I basically just mess with this number until it looks right. I think 0.3 maybe was the one I used. Okay. Oh, whoops. One thing I forgot to mention is that you should lock everything before importing with the thing, because it imports it like every path as a separate thing. So if you don't want it, it's like hard to get rid of. But if you lock everything else, you can just select everything and then delete it. First, So like if you locked it, you can't really delete it. I think I use 0.4. Cool.
So when
Lock everything else so that you can select the thing that you imported in and then drag it around, because each of the little boxes in the QR code is going to be its own thing. I'm pretty sure. Like kind of painful. So if you want to try those as well, it's a GitHub icon and then like a link icon. And then I'll just add like my website and GitHub here. And then let me show you what like how to make the thing shiny. So if we change this to top layer, that will like put a copper layer down. And then on top of it, we also want to add the top solder mask layer, but the top layer is on top, so you can't really see, but it's there. And then if we layer both of those, so we have both the top layer and then top solder mask layer. And then we can sort of see this. There's like the 2D and 3D buttons. You can kind of see the different like texture. Okay, and then we can add more art too. Sometimes when I have a bunch of different layers, to make it easier to align, I just like dump them all in Figma and then align them there. And then export them with like a rectangle in the corner so I can align them. But like, I just put everything on like the top layer for this PCB just for simplicity. But obviously there's like the bottom layers as well. So if you put anything on bottom silk layer, that will be on the bottom side in silk, or like bottom solder mask layer and bottom layer, you can make it shiny on the bottom. So if you want to do that, have different designs on both sides, you can do that as well. But this PCB is basically done. I don't know, it has my name, QR code, website links, fun art, and it should work when you use it.